Hi, Glendon. Hope for this helps. This is a pretty challenging problem, so if you can get through this, I think you'll be real prepared for the test tomorrow. All right, so step one, when I looked at problem 23, it does factor, and notice what I did in the denominator. To make my factoring easier, I just factored out the negative first. And that way, when I was left with the trinomial x squared minus 2x minus 3, I was able to just factor that into x minus 3 times x plus 1. So your denominator might look a little bit different than mine. But that didn't help me. I don't get any common factors. So the first step here is that it doesn't simplify. When I put 0 back into the original, I was able to eyeball it that all of these are going to cancel. So my y-intercept, I'm left with 6 over 3. And that's how I got 0, 2. For my x-intercepts, I looked at the numerator because ultimately when, let's get rid of that, when you set it equal to 0 and you cross multiply, the denominator goes away. So you're just left with the x plus 2 times x plus 3 equals 0. So that's why I'm getting my x-intercepts. And this behavior right here that's the thing that tells me something weird is going on. And I'll come back to that in just a minute. Because there were no common factors, you have asymptotes at 3 and at negative 1. X equals negative 1 and x equals 3. And I have those graphed here. You have the same degree in the numerator and the denominator. So the horizontal asymptote is y equals negative 1, which is your leading coefficients. So I plotted all of that. I plotted my asymptotes, I plotted my intercepts, and I plotted my my horizontal asymptote. Here's what bothers me. Just knowing that this point right here was my y-intercept, that probably made me understand that I had a branch in this region. What isn't intuitive is what is happening here. Because you've got two x-intercepts right here, I went ahead and said, okay, let's see what's happening in between them. And I picked negative 2.5, and I got just above the x-axis at 0.03. So I know it's not very much, it's very small, but I've got a hump here. And so that, honestly, if you're wondering, well, Mrs. Knapp, how would I know? Most of the ones that just have like 1 point, so I picked the 0.4 and got negative 8.4, and that's how I know I have a branch there. I would just keep picking points. Pick 5, pick 6, pick 7, and see what those points are to join. But when I saw that I had two x-intercepts right next to each other in this region, and you can't have a part of your rational function be constant, then I knew that in between those 2 points, it either had to be going up, or it had to be curving, that was poor, or it had to be curving, or it had to be curving down. One of those two things had to have been happening. And so that's really what I just picked. I picked the point in between them, saw that it went higher, and then that would probably cause me to pick points like negative 1.5. And then if I still didn't feel comfortable, maybe negative 1.3. And then you would have seen, oh, that pattern of behavior is going this way. And that's how it jumps the asymptote. If you wanted to graph this on a graphing calculator, another way that you know that it's jumping the horizontal asymptote is that if you look at the range, if my horizontal asymptote is y equals negative 1, you would look at the t-chart and you would see negative 1 in the range. And that tells you that you have a point defined somewhere on that horizontal asymptote, and so it's jumping. So I know that you're probably like, great, Mrs. Knapp, that doesn't give me a recipe. It doesn't give me a definitive answer. But when you kind of had weird stuff like that going on, where you had two x-intercepts side by side in that same region, so I had them in this region all together, that was my clue that I need to pick points closer around that points to really get a good view of what's going on. So if that makes sense, I think you're completely good to go for tomorrow. I really wouldn't be nervous. I think you're preparing very well. And please email me if you have any other questions. Have a good night.